Hello and welcome back to Calculus2. After 2 weeks, 3 weeks, eternity, whatever you want to call it, we are back in action. Partial fraction decomposition with revenge, right? So let's see. We need to continue semester online, obviously. I hope I have a whole bunch of you watching this stuff live. Those of you who don't make it live, you will have the video that you can watch at a later time. Type something in chat. Let's try this stuff out. Let's see who is online. So the goal is to work out a couple of exercises for partial fraction decomposition, and then see what else we can do. So the video will stay online. It will be on the channel. It will be added to, well, it will be as always, right, on the channel. I did upload all of the old Calculus2 lectures. So you should watch the videos before we meet so that we can work on problems as we go on. So let's see what can we do with partial fraction decomposition, and then we're going to see what we're going to do with the rest, exams and stuff. That's all gonna be on my MATLAB, so yeah, good luck with that stuff. You'd rather have Corona than take my MATLAB exams. Wow, that's a new one. Yeah, we are moving everything online, unfortunately. That's the situation we're in. So we're going to do the exams in my MATLAB. Unfortunately, that's the only thing we can do. Testing center is closed, everything is closed. So there are no other options. I will have the quizzes again and all of the good stuff. We still have exam 2, exam 3, and the final exam. If anything changes in terms of the department or the requirements or something like that, I will, guys, let you know. I mean, these are the options that I have. Now, this partial fraction decomposition part is going to be part 2. So we're just going to continue, work out a couple of examples. If you have any questions, I am monitoring the chat as I'm writing. So, any questions you guys have, just shoot them in chat, and then I will try to get to them as soon as possible, if it's something that I can answer on the spot. I need to find, so I'm going to work out a couple of exercises regarding partial fraction decomposition, and then we do have the rest of the chapter. So we'll go section by section. So tonight we are just testing this out. We're going to finish this, and that will be it for today. Thursday, we are going to push the next 2 sections. We will have 2 streams, one after the other, with a break in between. on Thursday to finish up chapter as soon as we can, because we are falling a little bit behind. So let's work out partial fraction decomposition. So for this one, before we left, we had these cases that you were supposed to memorize. And if you have a linear case, so if you had a linear, let me just get this, there we go. So if the denominator was linear, you would have this type of a setup, linear squared, right? So you are memorizing what situation you have, and then you use those formulas to work out problem. We talked about the procedure first, and then eventually we did integral problem. Here's one where we had a linear factor and then repeated quadratic. So this is the linear, and these two were for the repeated quadratic. This over here was formula 1, and this was formula 4 on the list. You were supposed to memorize those formulas and those setups, right, so that you can operate. Some algebra, and then finally we get to integrate. So we did a couple of examples, 3, 4, wow, I am impressed, 5. I should call this one done and done. And let's do a couple of examples to refresh our memory on partial fraction decomposition. On the exam, you are supposed to have 2 questions. One that should ask you to compute the entire thing, and the other one that would be just to set up variables without computing anything, because you might have 5, 6, 7 variables. That will be very annoying to compute. So I am going to now work out a couple of these exercises. So let's take a look at now I'm reading from a different textbook, so let's take a look at this problem. Now I lost it. There we go. So integral of 4x squared divided by x cubed plus x squared minus x minus 1 dx. So unfortunately we cannot use substitution or any other methods here, because it is not any of those, right? We have to use partial fraction decomposition. The way it's done is we have to factor denominator. Now factoring, we'll do that on the side. Let's go blue. I can group up x cubed plus x squared, and then factor out minus and have x plus 1 grouped together as well. Then kick out x squared and have x plus 1 in parentheses, minus another x plus 1. And now factor out x plus 1, which leaves us with x squared minus 1. And x squared minus 1 factors further into x plus 1, x minus 1. So finally we have x plus 1 squared x minus 1. So this algebraic manipulation is something you practice, obviously, in algebra, and then you just get to use it when needed, which is, in this case, we had to factor, right? So our problem is actually 4x squared divided by, I'll put x minus 1 first, and then x plus 1 squared second. And this is now we are going to do the setup, right? So the setup is going to be a over x minus 1. Don't forget the parenthesis. So a over x minus 1 plus b over x plus 1 plus c over x plus 1 in parentheses squared, because it's a repeated linear. So this gives us the setup, and then we are going to calculate A, B, C, plug them in, and then we will work on the integration for this. But let's first figure out what these are. So we have 4x squared over x minus 1, x plus 1 squared equals to a over x minus 1 plus b over x plus 1 plus c over x plus 1 squared. Okay, so I see a question on factoring. So let's see. So the question is, how do I get from the second blue step to the third blue step? Second blue step. Okay, so this is the question over here. The way I get to those is this one has a coefficient of 1 in front. So I pull what's common, which are these two are common. They go in front. And then the leftovers, which is x squared minus 1, goes in parentheses. So that should hopefully be enough for that. And the second question is asking us if it would be wrong to leave this as x plus 1 and then have another x plus 1 and then have x minus 1 and then avoid the repeated linear and just have 3 linears. And the answer is yes, it would be wrong because the setup is calling for repeated linears to have a different setup. That's why row 2 exists in the formula sheet. So we do have to go with the square and put these guys together. Awesome. So now we are going to multiply each one of these fractions with whatever it's missing in denominator to make a common denominator, which would be x plus 1 squared for the first one, and then x squared minus 1, which is x plus 1 and x minus 1 multiplied, and for the last one, x minus 1. So these are our multiplications, and we can lose denominators. Now they all have the same denominator, so we can just focus on 4x squared is equal to ax squared plus 2a x plus a, because there will be a 1 there, so it will be a, plus bx squared minus b plus cx minus c. There we go. So these 3 are from the first, these 2 are from the second, and these 2 are from the third. So we multiplied each denominator by what's missing. That multiplies the same into numerators. And since both denominators are, all denominators are the same, they just cancel. And we can just work with numerators now. Now it's our job to put like terms together. So over here I can say 4x squared plus 0x plus 0 if you want to. I have a plus b times x squared plus 2a minus, no, lies, times 2a plus c, those are times x. And finally, a minus b minus c is for the constant term. We go blue for the first one, a plus b equals 4. We go purple for the second one, 2a plus c equals 0. And we go, what, orange? For the third one, a minus b minus c equals to 0. Use whatever witchcraft you know to solve this system. No one cares which way you solve it, right? We just need these a, b, and c so we can plug them in the integral and do calculus, right? So some of you would probably add these two equations here because that would eliminate c from the system. So we have a plus b equals 4. That's copied the blue equation. And finally, 3a minus b equals 0 because c's are gone if I add those two. And now by adding these two, we eliminate b. I have 4a equals 4, a equals to 1. And as soon as I know a equals to 1, b must be 3, so they can make 4. And if a is 1, c is negative 2, because 2 times a, 2 times 1 is 2, and then I need minus 2 to get a 0. Perfect. So I have my a, b, and c, and I go back to the integral. A was 1, and that was over x minus 1. Then we have plus b, which is 3 over x plus 1. Let me see, just make sure that I'm getting this right. So a over x minus 1, b over x plus 1, and c over x plus 1 squared. So that's minus 2 x plus 1 squared dx. These are 3 separate integrals. And all we do is we integrate each one individually. First two are a joke, but the third one over there, you hope you see u substitution, right? So we have to u sub this one. U equals x plus 1, du equals dx, which means that we would be dealing with negative integral of 2 over u squared du. So that will be our integral at the end. This, maybe I don't need this negative, huh? We can just keep the negative in a problem. Yeah, let's kill the negative. So this is 2 integral of u to the minus 2 du, and becomes 2 u to the minus 1 over minus 1, right? All right, let's go. Well, let me just finish that off. So that's going to be negative 2 over u, and u is x plus 1. So what do I have? I have the first one there is going to be ln of absolute x minus 1 plus 3 ln of absolute x plus 1. And finally, minus and a minus will make a plus. So this minus and this minus make a plus together. So that's why it's a plus over here. We have 2 over u. And 2 over u is 2 over x plus 1 plus c at the end. I had a couple of you not put plus c on the exam 1, which is points lost, right? This is our answer. That's our answer. I'm looking for another exercise. Something that would be interesting. Well, let's see if you remember this stuff. Integral 0 to 1. So now we have a definite integral. We have to compute the value. So integral 0 to 1 x squared minus x divided by x squared plus x plus 1 dx. So we are going to do what? Can anyone remember what we're supposed to do in this case? Nice. Yes, 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 yes. Very good. Very good chat. So Ken said we are supposed to do long division because the powers on the leading terms are the same. So if numerator has a higher exponent or they're the same, we have to do long division, and then with whatever is left we use partial fraction decomposition. So long division on the side, we have to divide x squared plus x plus 1 into x squared minus x. I had last night, I had a lecture online with my pre-calculus course where I taught long division and synthetic division. So just 2 videos ago on the channel, or 3 videos ago on the channel, you will find my pre-calculus if you look in a chronological order. If you don't know how to divide polynomials, please go watch that video to learn, because any of these long division polynomials, calculators cannot do this, right? So calculator won't save you on a test of any kind, especially that this stuff is needed for differential equations. So differential equations for inverse Laplace transforms, you need to be able to work out partial fraction decomposition, and long division is the part of that as well. So make sure you can do this. All right, so the way we do the long division is we say we have x squared. So x squared goes into x squared once. Then we multiply back, we get x squared plus x plus 1, and we subtract. So first ones will cancel. We get negative 2x minus 1. And actually that's the remainder. There's nothing else there, so I can pull the minus and just have 2x plus 1 divided by x squared plus x plus 1. Please note that both of these I factor the minus that goes in front of the parenthesis. So you can either say plus and have both minus signs up there, or you can pull the minus. So the problem now is 1 minus 2x plus 1 over x squared plus x plus 1 dx. So now we see that we are in luck because we don't get to use partial fraction decomposition. This part over here is a basic U sub. Now, one thing that you all need to know is when you run into integral like this that looks like partial fraction decomposition, you cannot do partial fraction decomposition if you only have one factor in here. See, this cannot be factored, and it's single. So you can't do the setup for this. Because it's going to be only one setup. You have to have at least 2 parts to do 2 of those setups from the list. That's the minimum. You cannot have only one thing, one term, like you have it here, not one term, sorry, one factor, and do partial fraction decomposition. So this problem now turns into u sub. Now you would say, well, why the hell is this in the section for partial fraction decomposition? Because you're aiming to do partial fraction decomposition, you used long division to set it up for partial fraction decomposition, and then it turned out to be just a basic u sub, which means, hey, we are cutting out a lot of work here, which is awesome. So, woohoo! U equals x squared plus x plus 1 du equals 2x plus 1 dx. And that's exactly what we have. So first integral is integral 0 to 1 of dx minus the second integral is going to be du over u. And when I change my limits, when I plug in 0, I get a 1. And when I plug in 1, I get 3, right? I get 3. So I'm going to solve the x integral in x and just get my values. So that's x from 0 to 1 minus. And what's the integral of du over u? Someone will type that in chat. There is a delay, so I always have to wait for you to respond. What's the integral du over u? Yes, ln absolute u from 1 to 3. Great. Great, guys. So we have our 1 minus ln of 3 plus ln of 0. It's plus because you have a minus in front of ln and then minus from fundamental theorem of calculus, right? It's f of b minus f of a. So that minus and this minus here would make a plus. But it, sorry, ln of 1, not ln of 0. But ln of 1 is 0 anyway, so we don't care. And the answer is 1 minus ln 3. That's the... good. So that was a nice problem. We did not have to do much over there. Should we do another one? And then see what else we can do? Say no more, huh? So let's see. I like these that are not factored because we have to actually do some work. X squared plus 3x minus 4 divided by x cubed minus 4x squared plus 4x dx. So x squared plus 3x minus 4, x cubed minus x squared plus 4x. All right, let's see. Let's see. Well, we factor first, right? We can kick x out, and that leaves us with x squared minus 4x plus 4. And that's it. I don't think this can be factored any further because you can have this needs to be a plus over here in order for us to have that to be factored further. I think we're done here. That's it in terms of factoring. So we have a setup that is a over x plus bx plus c over x squared minus 4x plus 4. So this is formula number 3. I don't even know if we used it yet. So we have x squared plus 3x minus 4. And give me 1 second, I have to answer the chat question. For the chat question, that will be x squared minus 4. So here we go. We have x squared plus 3x minus 4 divided by x cubed minus 4x squared plus 4x. And then we would have, oops, on the left-hand side, we have our a over x plus bx plus c divided by this x squared minus 4x plus 4. So we're going to multiply the second one by x, because that's what we're missing. And the first one gets multiplied by x squared minus 4x plus 4, right? So we have x squared plus 3x minus 4 divided by x cubed minus 4x squared plus 4x equals 2. Well, actually, we don't need these denominators. Just denominator will be the same on both sides, and we'll just cancel them. So just get rid of it. Done, lost. We have ax squared minus 4ax plus 4a plus bx squared plus cx. Hold on, there is a question in chat. I'm saying, doesn't the next factors over? If it does, I'm going to start crying. Let me see. X minus 2. Give me 1 second. Square the first minus the get rid of everything. You're right. Good job. Yep. All of this is bad. All right, let's kill all of this now and go back to no. I gotta. Just give me an hour. I'll be right with you. This problem works out to be the same as the previous one. Boring again. So x minus 2 squared, and we have exactly the same what we had earlier. Not fun. Not fun. We have b over x minus 2 and then c over x minus 2 squared dx, and this turns out to be pretty much the same as what we had before. Alright, so what do we have? A needs to be multiplied by x squared minus 4x plus 4. b needs to be multiplied by x squared minus 2x, and c needs to be multiplied by x. X squared plus 3x minus 4 equals to ax squared minus 4ax plus 4a plus bx squared minus 2bx plus cx. This is awesome. And what do we do now? We set up x squared plus 3x minus 4 equal to a plus b, that's for x squared, plus, then I have negative 4a minus 2b, or not 2b, plus c. There we go, that's times x. And then we have plus 4a. Awesome. Below is a plus b equals to 1. Purple, negative 4a minus 2b plus c equals to 3. And finally, orange, negative, no, lies, 4a equals negative 4. Great. Now we have a system. A is negative 1. If a is negative 1, b is 2, because blue, right? And then the purple equation gives me 4 minus 4c is 3. Right, because a is 2. No, a is negative 1. That gives me positive 4. And then plus 4 minus 4, that cancels, so c is 3. So we are going to now set up. Hi, Rory. Yeah. We'll see you, buddy. We're going to set up now negative 1 over x plus 2 over x minus 2 plus 3 over x minus 2 squared dx. And that one requires a u sub, right? Of u equals x minus 2 du equals dx. So that becomes 3 over u squared. So I have what? I have negative ln of x plus 2 ln of x minus 2 plus 3 times. Now the integral over here is going to be negative u, so 3 over x minus 2 plus c. There you go. Woohoo! So I hope that, I mean, we can flex a little bit with these things to compress these answers. Some of you are into computer science, and you should always simplify your answer as much as possible to get to the place where you have the least amount of operations. So technically, you should be compressing these, especially if you're computer science. I mean, the rest of you, I really don't care whether you compress or not. But computer science guys, you should be doing this. So the power of 2, right, would go and square x minus 2. That one is a positive term, it stays on top, and then the minus ln, so the x would go into denominator, and then the second term stays as is. So this has less operations for a computer to calculate, so the software will be working faster, so computer science has another answer over here. That's partial fraction decomposition. You have to memorize those 4 setups, and then you have to use them to set up. Hopefully you are able to factor better than I am. So you can see those. And not every problem for partial fraction decomposition is partial fraction decomposition. You have to be careful, right? Some of those would be the trig sub, right? So you have to be careful not to confuse these things. Some of those trig sub problems would ask you to complete the square, and you would get a trig sub problem rather than partial fraction decomposition, but it might look like it's partial fraction decomposition. So the next 2 sections will help with determining which test we are, which integration technique we are supposed to use. And then I believe after that we only have 1 section left for the end of the chapter, and we should be talking about the exam, I guess. We still have at least 2 weeks before we get there. I mean, this week on Thursday, and then next week to finish the material. So exam could, I think, earliest be the first week of April or second week of April, something like that. So let me see, Tuesday, Thursday, yep, Thursday, and then Tuesday. Yeah, we should be done by April 2nd. We should be done with all of the material. We could also do the review, and then have some form of so you can pick. Now in terms of exams, they will be done on my MATLAB. You will have, I was thinking to bump it up to 2 hours, because my MATLAB gets to be a little bit tricky with these things. And let's go with that, and then you will have 2 hours from the time you click to do your test. So you will be working, I'm going to leave the test open for 24 hours, so it will start at noon on one day and it will end at noon the next day. So if you want to do this at 4 a.m. then you can, but whenever you start the quiz or the test, the exam will be timed, and it will just shut off 2 hours later, or I might make it shorter to put I don't know, we can talk. If you have any suggestions, shoot them over in an email, and we'll figure out what to do with the rest. You saw that exam 1 grades are posted. I do have tests over here in quarantine with me, so we can talk about that stuff at some point, or if you have any particular questions, we can deal one-to-one. So I'm going to open all of my MATLAB right now, and it's the grades for my MATLAB, I believe they will arrive after everyone is done. So the grading for the exam will be available, I believe, an hour after, so at 1 p.m. the second day, right? So the exams end at noon, and I believe at 1 p.m. exam grades will be available. Now those grades will be posted on Canvas along with because remember, I still have to add quizzes into the grade. So you will see your MyMathLab grade for the test, but the grade with quizzes added, that will be, added later into Canvas. So at some point in life, that will be added. In regard to the exam, in terms of the problems similar, the answer is yes. If you want to see every problem that is possible on the test, you just need to do every single problem that exists in a study plan. Study plan contains 100% of problems that are programmed in MyMathLab. So if you go to study plan and do every single problem that exists in chapter 8 in the study plan, you will definitely work out every exercise that will be on the test, because that's the bank. Study plan is the bank from which we pull homework, we pull quizzes, we pull tests. There are no exercises outside of study plan. So if you go and you do the whole study plan, you will definitely hit every single, right? So there will be a day, noon to noon. You will have hour and a half or two, depends on how long it works out to be. If there are any accommodations, that MyMathLab will adjust for that, if there is extra time or something like that. Then the grades, the MyMathLab will display the grade for the exam, I believe, an hour after the exam closes. The Canvas will have a different grade, obviously, because we still need to add those 7 quizzes. So Canvas grade should be by 7 higher. I know not everyone does all the quizzes and stuff, but let's hope they do. And then the problems will be the problems you have seen on the MyMathLab homework, MyMathLab quizzes, MyMathLab chapter test. But if you really want to see every single one, just do all of the study plan, which is 100% of what's available in MyMathLab. Yes, I will choose the questions. Do you know anything about possible pass-fail situation being... I'm not sure what that means, Chris. I'm not sure what that question means. Possible pass-fail situation. The class is continuing as usual, except we're just going to have the online testing now, because the testing center is closed and the site is closed. So we'll have to figure that out. The email from the president stated clearly that the college is closed throughout spring 2020. So there will be no live classes held on campus. And we still don't know anything about summer 1, summer 2. We are going to be purely online and not have any of the meetings at all for this. Oh, I see. Okay. So, yeah. So MyMathLab does have the famous thing, you answered one thing and they say, no, that's wrong, correct answer is, and then they put exactly what you put in. I did some digging into it, and this is what we found. In some cases, when students cheat, they use other website, external website, and then they're even lazy to copy the answer. So they do Control-C, Control-V from one website into MyMathLab, and then the spacing is off because it's not read the same by the code. And the MyMathLab is, so if you carefully look at some of the memes that were going around regarding MyMathLab, you can see that the formatting given in the answer and the formatting given by the MyMathLab is slightly off. So that's a big deal, obviously. Now, the trick about Calc2 class is when you cheat in Calc2 class, then you're dead in differential equations, because if you don't know these sections, DFQ is just impossible. I mean, it's brutal. So, there is no way for me to, police about that, but you will be self-sorted once you hit DFQs, right? That's the way it goes. So, in terms of the answers, I will be reading the answers just like a regular exam to see. Some professors are requiring pictures of the work to be emailed. So you take your phone, you take pictures of the work, and you email them either through Canvas, upload the file, or you email it in the email. I'm still not sure how all of this is going to work. I'm kind of waiting for some of my colleagues to have the first experience, and then I'm just going to steal what's the best from them. But some professors will be requiring the pictures. So that might be something I might do as well. I don't know. I definitely want to make sure that you guys are not losing points because of the either formatting issue or, partial credit obviously is issue, whole bunch of stuff, especially in those stressful conditions. My MATLAB tends to be finicky, and, we have to figure, it's the best software out there right now. So we are using it. But we don't have any other alternative. Such is life, Yeah, I see the cameras are now breaking on the phones as well. Yeah, as I said, right? It's time to upgrade those garbage iPhones into real phones, people. Let's go, chop, chop. I think discounts are hitting the stores now. No one is buying anything of it, time to upgrade, get the real phone. You're sitting in Calc2 class. You should not be using Apple devices and grow up, right? So we'll see. There is a lot of stuff that we need to work out. So we'll deal with Thursday first. So next 2 sections on Thursday, 2 streams back to back. I am experimenting with Zoom. I might use Zoom for office hours. I am trying to figure out that part. So, we'll have to figure out things. We will have to figure out what to do with all that stuff. So that's it for now. I'm gonna hang out a little bit more in the chat, and then we'll deal with the situation as stuff comes up. Nothing we can do about. We can't go to campus. We can't meet, and we'll see. We'll see how it goes. Just keep monitoring. Stay safe and wash your hands, I guess. That's it. All right, I'll see you guys. I'll stick around in the chat.